we're going to start graphing trig functions. We've already graphed sine and cosine, just the basic non-transformed functions, but we're going to start graphing them with transformations, and then later we're going to graph tangent, cosecant, and secant, and cotangent. So before I start that, I really would like to explain what a radian is. We're used to measuring angles in degrees. Another unit of measure for angles is radians. And it's no different than feet are to centimeters. It's just a different unit, a different way of measuring the same angle. So I found something on the internet. I'm going to play it for you. Oops, went ahead more than I wanted to. But here we go. So this will explain what a radian is.
Two methods are typically used to measure angles. They involve degrees and radians. The Babylonians chose to divide a circle into 360 sections. Select Next to learn why they picked the number 360. One theory was that 360 was chosen because the Babylonians believed it took 360 days for the sun to pass around the earth. Whatever the reason it was selected, the number 360 carries no special significance when working with circles or triangles. Radian measure is based not on a number chosen by man, but on the basic components of a circle. A radian is the measure of the central angle subtended by an arc equal in length to the radius of a circle. A central angle has its vertex located at the center of a circle. This is subtended by an arc equal to the length of the radius. The green sector represents an angular measure of 1 radian. Let's view an illustration of 2 radians. How many radians are equal to 1 complete revolution? The circumference of a circle is equal to 2 pi times the radius. Remember, pi is the ratio of the circumference of a circle to its diameter. As you know, there are 360 degrees in a circle. Therefore, 1 revolution equals 2 pi radians, or 360 degrees. 1/2 revolution equals pi radians, or 180 degrees. And 1/4 revolution equals 1/2 pi radians, or 90 degrees. Therefore, there are 2 pi radians in a circle. Demonstrate your knowledge of radians by answering the following 3 multiple-choice questions.
Okay, we're going to stop there. So now what we found is that we know what a radian is. It is the 1 radian is the, why is my pad not working here? Here we go. 1 radian, here we go. 1 radian is the length of the radius around this edge. So my arc length there is 1, and this is 1 radian. Now, what we've been graphing when we graph sine and cosine is the length of the intercepted arc on this circle. It just so happens that since we've been dealing with a unit circle, the length of the intercepted arc of my central angle is that angle's measure in radians. So as I've been having you memorize the different parts around the circle, different arc lengths around the circle, what you really have been memorizing are radians. So there's some critical values for sine and cosine I want you to remember. These are going to be our parent functions, and we're going to transform them. So for sine, starts at 0. At pi over 2, it goes up to 1. At pi, back down to 0. 3 pi over 2 goes back down to -1, and 2 pi back up to 0. So copy these down. If you need to press pause, go ahead and pause, and then when you're ready to move on, press play. Okay, so we've graphed sine before, but we really haven't talked about amplitude. We have talked about period. The period, as you know, for sine is 2 pi. The amplitude is the maximum value minus the minimum value of y divided by 2. So in this case, I'm looking at sine. My maximum value is 1. My minimum value is -1. The amplitude is 1/2 1 minus a -1. So that's 1 plus 1, which would be 2 over 2 or 1. Another way to think about the amplitude is the distance between the midline and the maximum value and or the minimum value. So the distance between here and here is 1. That's an amplitude. Now, I graph sine between 0 and 2 pi. A nice way to find these values on the x-axis is to find where you're graphing between. We always graph one period. So here, between 0 and 2 pi, halfway between 0 and 2 pi is pi. I get that by taking 0 plus 2 pi and dividing by 2. Halfway between 0 and pi is pi over 2. That is the midpoint. 0 plus pi divided by 2 is pi over 2. Halfway between here, 3 pi over 2. Same idea. Pi plus 2 pi over 2, 3 pi. The domain, as we know for sine, is always all reals. And the range is between -1 and +1 inclusive. So now we're going to take that idea and we're going to transform. And remember transformations, we have our A out in the front, that is my vertical stretch and shrink. B is inside my function as my horizontal stretch and shrink. And then C is my horizontal shift, D is my vertical shift. Remember that this B needs to be factored out. Now, I can do exactly what we've been doing for all of our other parent functions, where I have my xy chart, I divide by b, I subtract c. On my x's, on my y's, I multiply by a, and then I add d. I'm going to do trig functions just a little bit differently than that. So I'm going to work through this with you, and then I'm going to make a list of exactly the steps involved in doing this. So the first thing that I need to do is identify what a, b, c, and d are. A is -1, b is 1, c is -pi over 4, and d is 2. Now, the first thing I'd like to do is figure out the period of my transformed graph. The parameter over here that affects the period is b. We always find our period by taking the parent function period divided by the absolute value of b, because if you remember, b is your horizontal stretch shrink. If b is large, it causes it to stretch. When I say large, an absolute value greater than 1 causes it to stretch. No, sorry. If the absolute value of b is greater than 1, it's going to cause it to shrink. If absolute value of b is less than 1, it's going to cause it to stretch. So we divide by the absolute value of b. In this case, b is 1, so my period stays 2 pi. Now, the next thing that I'm going to do is I'm going to find the values on the x-axis I'd like to plot. Remember, we are going to graph one period. So, usually, for any kind of transformations, I graph between 0 and 1 period, which in this case is 2 pi. Now, the difference is, though, that my c value has caused my graph to shift to the right, because remember, we subtract c. So I am going to subtract -pi over 4, which is the same as adding pi over 4. So now I'm going to graph between pi over 4 and 2 pi. 2 pi plus pi over 4 is 9 pi over 4. Now I have the endpoints of the period I'm going to graph. So I'm going to draw this on my x-axis. I have pi over 4 here and 9 pi over 4 here. Now, to find the other values I'm going to plot, I'm going to find the midpoint here. Pi over 4 plus 9 pi over 4 is 10 pi over 4 divided by 2. Well, 10 pi over 4 is really 5 pi over 2. Divided by 2 is 5 pi over 4. Pi over 4 plus 5 pi over 4. Boy, this looks an awful lot like a 9. Pi over 4 plus 5 pi over 4 is 6 pi over 4, which is really 3 pi over 2. Divide by 2. That's 3 pi over 4. You'll notice I can find the midpoint here, or I can notice that I am adding 2 pi over 4 every single interval. And what I would end up with here is 7 pi over 4. Or I could add these two and divide by 2. It really doesn't matter. Now, the amplitude of these trig functions of sine is always going to be the absolute value of a. In this case, a is 1. My absolute value of a is 1. Now, I really need to know the pattern for sine. Before I do any plotting, though, I've got to take care of the fact that this has shifted up 2. So I am going to transform my x-axis up 2 places. I don't know why that's not going away, but we'll go with it. All right, so this is now moved up 2 spots. And now I have a transformed x-axis, which is going to be my way of knowing where this graph gets plotted. Now, sine always starts on the x-axis. Now it's going to start on my transformed x-axis. It generally will go up in amplitude, but since a is negative, it's going to go down in amplitude here, down to 1. Then it's going to go back up to my x-axis, back up in amplitude, and then back down to the x-axis. So then we will draw in our curve. I'm having a hard time drawing it. There we go. So that is sine graphed. We still need to identify what the domain is. Domain for sine remains unchanged regardless of what the transformations are. The domain is all reals. The range goes from -1. Sorry, that was the old. That was the old range. Now, if we look at our graph, the domain goes from 1 to 3. And now we have a beautiful graph of sine. So now I'm just going to summarize what we did. The first thing that we had to do was we needed to determine the period. We do this by taking our parent function period and dividing by the absolute value of b. The next thing we did is that we found the x values to plot. And we do this by finding the endpoints. So we'll take between 0 and 1 period, in this case 2 pi, of our graph. This is the 2 pi I'm talking about here, this 2 pi. Between 0 and 1 period, and then I am going to shift, I'm going to subtract c so that I now have my new endpoints, and then I will find the midpoint between my endpoints, and then the midpoint again, plot them on my x-axis. So I got to find the x values. That's step 2. Step 3 is to transform the x-axis. By d. So it's going to either go up because of d if d is positive, up if d is negative, down. Then I have to find the amplitude and plot. The amplitude is equal to the absolute value of a. So you're going to do that by following the pattern. That's my dog. All right. And again, sine generally starts on the x-axis, goes up an amplitude, back down to the x-axis, down an amplitude, and then back up. But when a is negative, it flips. So starts here, goes down, back up, down. And then you identify the domain and the range. The domain, again, is all reals. The range, you can see from your drawing. In this case, it goes from 1 to positive 3. Now, the next thing that I'd like to do is talk about cosine. And again, we've graphed this before. We know the period is 2 pi. My amplitude, again, is the maximum minus the minimum divided by 2. Amplitude is 1. It's the distance between the x-axis and my maximum point and my minimum point. So here are my critical values for cosine. This goes between 0 and 2 pi. My midpoint here is pi. Between 0 and pi, the midpoint is pi over 2. And between pi and 2 pi is 3 pi over 2. It's important that you know the pattern for cosine. It starts up an amplitude, goes down to the x-axis, down an amplitude, up to the x-axis, and then back up an amplitude. So the domain is all reals. The range is from -1 to +1. So now we're going to do another graph with cosine, only this time transformed. Let's see if I can move this over. There we go. I purposely did this with the b not factored out. It's really important that that be factored out. So I'm going to do that right now. Okay, so now I can identify what A, B, C, and D are. A is 1/2, B is 4, C is -pi over 2, D is -1. So my period, that's the first thing, remember, we had to do. We have to determine our period. It's going to be the period of my parent function, which in this case is cosine. So 2 pi over b, and b is 4. So my period is pi over 2. All right, that was step 1. Now let's go back and look just to make sure we're following this the way we want to do. Okay. So remember, the first we found the periods. The next thing we did was we found the values on the x-axis. So let's work on that. So again, we graph between 0 and 1 period before there's any kind of shifting going on. And my period in this case is pi over 2. Now, C is -pi over 2, so I'm going to subtract that, which is the same as adding pi over 2. So now I'm going to graph between pi over 2 and pi. I got that again by adding pi over 2 to each of these values. So I'm going to plot those, pi over 2 and pi. Now we'll find midpoint here. So pi over 2 plus pi over 2 is 3 pi over 2. Divide by 2. That's 3 pi over 4. Add these two together and then find the midpoint again. Let's see. 2 pi over 4 plus 3 pi over 4 is 5 pi over 4. Divide by 2. 5 pi over 8. Add these together. 3 pi over 4 plus 4 pi over 4, 7 pi over 4. Divide by 2, 7 pi over 8. So now I have the values on my x-axis that I'm going to plot. Now, let's transform the x-axis. So I know my x-axis is going to shift down 1. So I'm going to draw in my transformed x-axis. Let's see here. This looks good. and it moved down 1 to -1. All right, now the amplitude. The amplitude is A, so I know that my amplitude is 1/2. And now it's time to plot, and I'm going to use a different color so it shows up a little bit better. Cosine starts up in amplitude. So up in amplitude from -1 is -1/2. So it's going to start here. It's going to go down to the x-axis. It's going to go down in amplitude to -3/2. Back up to the x-axis, and then back up in amplitude. So draw it in. Oh, I don't like how that's coming out. Let's make that more curved. And there is cosine. And again, my domain, all reals. It's all reals always, no matter what the transformations are for cosine. And the range goes from -3/2 to positive, or to -1/2. And there you have it. So now I'm going to have you work on some problems so that you can practice. The answers to them are on my website. Have a wonderful day.